Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and this is just going to be a fun one. At least I hope you find it fun. I took a look at the weather balloon data from Greensboro this morning at 8 o'clock and took a look at 3 variables in that, pressure and altitude above the ground and temperature, and wanted to see how those 3 variables all relate to each other. And so that's what we're going to be doing today. So I guess the pressure is on, and we'll see if the temperature and the altitude vary accordingly. So let me put myself down here in the corner, and let's take a look at the first table here. Now, Greensboro is 270 meters above sea level, and the data that's reported to us from the weather balloon is actually in elevations above sea level, but I felt like it would make more sense to you if I subtracted out that elevation above sea level and actually took a look at what was going on above ground level, okay? So that 270 meters is accounted for there. And you can see that right at the surface, the temperature was 75.9 and the pressure was 28.94. Now you might be thinking to yourself, Greg, I have a home barometer and most of the time it's around 30 inches, give or take a little bit. That seems awfully low. Well, the reason it's low is that Greensboro is 270 meters above sea level. And when we plot weather maps with isobars on them, if we just took the whatever the station pressure was at whatever elevation that station was at, then all the lows would be over the mountains and all the highs would be over the ocean. Well, we're not interested in that. We want to know where the actual weather systems are, so we have to standardize the pressure and reduce all of these stations, what we call reduce them to sea level. And the way that's done is that there is a standard atmosphere that has certain definitions in terms of lapse rates and so forth. And so what they do is they apply that standard atmosphere to each station. So if Greensboro could be taken down to sea level, then this is what the pressure would end up being, and it's considerably higher than 28.94. It's probably in the 29s, high 29s. So that is the station pressure, and the pressure that you see on a weather map is that pressure reduced to sea level, which is going to make it higher, and the farther you are above sea level, the more of an adjustment you have to make, okay? So let's go on ahead here, and over the lowest 1,700 feet, there was a little inversion where the temperature actually went up almost 2 degrees. This is typical on a fair night with light winds. The cold air is going to collect, or the coldest air, and I use cold loosely here, will collect near the ground, and then once the sun comes up, it burns that inversion away, and the temperature decreases with height from the ground all the way up. So once we get up to about 7,500 feet, we're down below 60, and by 13,500 feet, we're below 40. By 23,379 feet, we're below 10. And we just keep on going. At the bottom there, you see the elevation 33,668 feet, or about 6 1/3 miles. Our temperature has dropped to 30 below zero. And notice the pressures over on the right. They're decreasing steadily as well. And by the time we get to that 33,000 elevation in feet, then our pressure is 7.94 inches of mercury. So when you compare that to 28, that's about 25%, okay? So 75% of the mass of the atmosphere is basically below 33,000 feet. Now, let's go on ahead and take a look at the second set of numbers here. So notice that the temperature continues to go down, and by the time we get to 50,377.3 feet, or about 9.5 miles, the temperature has dropped to minus 98.9 Fahrenheit. That is cold, and the pressure at that altitude is 3.57 inches of mercury. So again, you're used to seeing it around 30, okay? Just divide that by 10, and that's what your pressure is up there. Then notice that as we go higher, the temperature begins to increase with height, and by the time we get to the highest level the weather balloon was capable of observing data today, it was 103,264.4 feet above ground level, or about 19.5 miles, and the temperature had warmed from minus 98.9 to minus 44.5. And the pressure at that altitude, 0.28 inches of mercury, okay? So not a lot of air once you get up to 103,000 feet. Okay, so let's now graphically take a look at how these variables relate to each other. And the first one, I talked a little bit about this, I think, just a couple of days ago, where the pressure decreases what we call logarithmically with height, okay? So the pressure is along the x-axis down here along the bottom, and the height above ground level in feet is along the y-axis. So the pressure is decreasing very quickly in here with altitude, but then as we get higher and higher, that rate of decrease really slows down to the point where it's almost constant, just decreasing very, very slightly with height as we get up here toward the top of the graph. And you would expect this. Gravity is strongest at the ground, and so it's going to pull a lot of the mass of the atmosphere right toward the ground. And then as gravity weakens as you go up, the atmosphere is going to become less and less dense, and the pressure is not going to decrease as quickly with height. Now, what about temperature? Well, here is that graph, and you can see that little teeny inversion right there where the temperature went up a couple of degrees over about 1,700 feet, and then it started to decrease very, very rapidly above that, and you get up to about 50,000 feet, and there's that minus 98.9, and then the temperature begins to increase with height up to about that minus 44 by the time we get up to the top of the graph. So this layer down here is called the troposphere, which is where all the sensible weather occurs. That's what meteorologists that are involved in forecasting the weather focus their attention on, because just about all the action goes on there. And then right where you change from decreasing with height to increasing with height, that's what we call the tropopause, which is a fancy word for the top of the troposphere. And then above that, you've got the stratosphere, where the temperature is increasing with height. That's the layer of the atmosphere where the ozone is located and has the ability to protect us from the dangerous ultraviolet rays coming in from the sun. But again, the stratosphere is not an area that meteorologists, at least those that forecast the weather, concern themselves with very much. And the height of the tropopause actually varies with the time of the year. When it's warm, it's pretty high up. But as we get into the winter season, the troposphere is actually shallower and the tropopause is lower. And that sort of makes sense because the air is colder and it's more dense, and so it's not going to take up as much space. Whereas in the summertime when it's warm, it does take up more space, and so the tropopause is actually quite a bit higher at that time of year. Alrighty, there are your credits. That is the bonus weather video for this Wednesday. Hope you found that fun and interesting. The next bonus weather video will be coming up on Friday. The next daily weather update will be coming up later this afternoon. I actually posted the bonus weather video before the daily weather update today, because for once in my life, on rare occasions, I actually plan ahead. So it's actually, I don't know why I don't do this more often, because it's actually a lot less stressful to do it this way. All right, folks, that's it for now. You all have a wonderful rest of your afternoon, and I will talk to you with the daily weather update in a few hours. So we'll see you then. See you later.